Hi friends, welcome to our channel. Here let's look at this problem, count days without meetings. First, this problem is an interval watch type problem. We are going to do it using a linear scan. Here, for the purpose of teaching or pedagogical purpose, so we are going to use a stack data structure. Explicitly. This is not absolutely necessary, but it's good to use it to print some information so that the explanation is easy to be digested. So here we are given a positive integer called days, representing the total number of days an employee is available from day 1, right? So we are also given a 2D array called meetings, where meetings is essentially an interval, a closed interval, right? So we want to return the count of days when the employee is available for work, but no meetings are scheduled. So here, if you look at the 3 examples, example 3 is special because every day is occupied, so the output is 0. For the second example, we know the 2 intervals have overlap. So it actually expands from day 1 to day 4. Therefore, there's just 1 day available. So in the first one, the 3 intervals are non-overlapping. So first one expands 3 days, second one 3 days, and third one 2 days. Overall 8 days. So the available time is 2 days. So here the length of the meetings can be as long as 10 to the power 5, basically giving the size of the problem, and days can be as large as 10 to the power 9. So with that said, I guess we are ready to do the coding. So as I mentioned, so we are going to implicitly using a stack. So the purpose for using this stack is to later make some prints so that you know what's going on under the hood. So here, first, I'm going to get the length of this meetings, right? So the overall logic will be this. So the number of days minus days with meeting, right? So we need to correctly count this total number of days with meeting. Then once we get this information, this will be the return. But you know, in view that some intervals can be overlapping, therefore we need to merge that to correct counting. So first, in order to achieve this, we can do a sort in place. So here, our main purpose is to make the meetings sorted according to their starting time, right? So here also I'm going to introduce a stack. So first I'm going to put the meeting index with index 0 here. So this way actually brings some convenience in writing. So now we are going to do the linear scan. So for I in range 1 to n, right? So we can get the previous start previous and end previous will be the stack top element. And then we have the current start and end, that will be meetings I. So notice that this is after sorting, right? So in other words, we always have s previous is less than or equal to s. So then we want to consider if we need to merge the 2 intervals represented by this line and this line. So if s is strictly larger than the previous end, so in this case, no overlap, we just need to stack append the current interval, right? Otherwise, there will be overlap. So then what we are going to do, we form a new interval. So let's call it temp. The temp will be the smaller of the start, so that is s previous, and the larger of the end, so it's e previous and the current e, right? So we are going to pop the current stack top element, and then we do stack append the current merged interval. So this way, after the for loop, we actually merged all the intervals, all the meetings. Then we can do the computation. So this will be rather straightforward. So we're going to return days minus the summation of the meetings. So now the meetings in stack are non-overlapping. So we're going to do is e minus s plus 1 for se in stack. So that will be the full coding. Actually, it's rather short. So now let me first do a test. Yeah, it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, with this done, let me make some comments. First, temp complexity. So here we are using sort, right? So it's O n and logarithm n. And also we have a for loop that will be O of n. So overall, it will be induced to O n logarithm n, because linear is increasing slower than log linear, right? No, linear times logarithm. So this is the temp complexity. The space complexity here will be O of n, the length of these meetings. So because of this introduction of the stack. So actually, a natural extension is that can you write it just using O1 space. This is very straightforward. So this is the first one. And the second one is that let's print some information. So here, let me print out this stack state. So here I'm using f string. So for the first example, see, there's no overlapping because we have using sort. We should have 1, 3, and 5, 7, and 9, 10, right? So you can do the algebra. 3 minus 1 plus 1, 3. 7 minus 5 plus 1, 3. 10 minus 9 plus 1, 2. 3 plus 3 plus 2, 8. 10 minus 8, I have 2. So for case 2, so in the stack will be a merged interval that will be from 1 to 4. So the duration is 4. So 5 minus 4 is 1. So for the last one, because it's just 1 itself, just 1 interval, so we get 0. So this is the second part. That's also why we use this explicitly using this stack. In principle, you don't need to use it. So we have a playlist for interval merge type of problem. So you can check out those videos, and hopefully those videos will help you get better digestion or understanding about this type of problems. With that said, I guess that's it for the current video. Thank you for watching.